Good morning, students. In this video, we are going to discuss about multiple bus organization, its data path and control sequence. So, which is coming under the module number 5, basic processing unit of the course, computer organization and architecture. Let us discuss in detail about the multiple bus organization. So, what actually a multiple bus organization? In the multiple bus structure, which has various devices that have different transfer rates can be connected. At the same time, a maximum throughput is maintained, hence which is primarily used in industrial systems. Let us discuss about some of the benefits of the multiple bus organization. This multiple bus organization allows more number of devices to be connected to the computer, and because of that it's going to have a faster execution because many devices can work simultaneously, which results in performance enhancement. Meanwhile, it's going to be more compatible with both old and new devices with new versions, so that here the multi-core processor that transfers more information and which minimizes the waiting time of the processor for the process of execution. These are the benefits of the multi-bus architecture. Okay, what actually the need for multi-bus organization? If you're going to see about in a single bus organization, only one data word can be transferred over the bus in a single clock pulse or single clock cycle, which increases the steps required to complete the execution of the instruction. Since what happened, the delay is going to be get produced, or delay is going to be get more in that particular single bus organization. Hence, which results the control sequence are quite long because only one data item can be transferred over the bus in a clock cycle. So, to reduce the number of steps, most processors provide a multiple internal paths. This multiple paths enables several transfers to take place in parallel. So that what happened, this figure which is going to dissipate a 3-bus architecture which is used to connect the registers and the ALU, nothing but the arithmetic logic unit of a processor. Here, all the general purpose registers are connected to a single block called as register file, which is going to be called as a register file. In the VLSI technology, the most efficient way to implement a number of registers is in the form of an array of a memory cells, similar to those used in the implementation of random access memories, RAMs, isn't it? Such a way it's going to be get connected over there. So here there are two outputs allowing the content of two different registers to be accessed simultaneously and have their content placed on the bus A, input A and B. I think but the bus A and the bus B, and the output of this ALU can be placed on the bus C. Let us discuss about that. So the register file has 3 ports which has 2 output ports connected to the bus A and bus B. The third output port allows the data on the bus C. Such a way it's going to be doing its operation. And the bus A and B are used to transfer the source operand to the A and B inputs of the ALU, where the ALU consisting of 2 inputs A and B, which is going to be get the data from the bus A and bus B. Meanwhile, what happened? The arithmetic or logic operations are going to be get performed with the ALU, and the result is going to be transferred to the destination over the particular bus C. If needed, what happened? The ALU may simply passes one of its 2 input operand unmodified to input the output as output for the bus C. Such a way it's going to do its operation over here. And move on to this, the ALU can also pass one of its 2 inputs as an unmodified. For example, the control signals such as an operand, control signal such as an operand R may be equal to A or R may be equal to B. Such a way it's going to do its operation. And one more feature if you're going to see about this particular diagram, which has an incrementer. So this multi-bus architecture which consisting of an incrementer. So this incrementer which is going to be introduced over there as a unit which is used to increment the program counter by 4. So the source for the constant 4, the source of the constant 4 to the multiplexer at the ALU, the input of the multiplexer is still useful over here. It can be used to increment the other address such as memory address in the load multiple and store multiple instructions. Such a way this multiple organization is going to be helpful for us to do this operation. Let's have an example to describe or to understand about the multiple bus organization in detail. The instruction which have been given over there is nothing but add R4, R5, R6. So this is a 3 operand instruction. What actually is going to do that? Let us see about the control sequence of the instruction add R4, R5, R6 which have been given for this 3 bus organization. So if you're going to see about this figure which explains about the execution of this control sequence for the instruction add R4, R5, R6. The step 1, the content of the program counter are passed through the ALU using the register R is equal to B control signal, and which is going to be loaded into the memory address register so to start a memory to a read operation. At the same time, the program counter is going to be incremented by 4. Note that the value loaded into the memory address register is the original content of the program counter. The incremented value of the program counter which have been loaded at the end of the clock cycle and will not affect the content of the memory address register during the execution of the during the fetch cycle of the first step. The second step, which is going to wait for the memory function completes. Okay, the processor is going to wait for the memory function complete instruction. Then the step 3, what happened? The processor loads the data received into the memory data register. Then it is going to be transferred to the IR register through R is equal to B, and which is going to be transferred to the instruction register. Then the fourth step, which is going to be the execution phase. As already we discussed about that, first 3 steps are going to be called as fetch cycle. The fourth step is going to be, from the fourth step is going to be called as execution. Here the fourth step, which is going to be entering into an execution phase of the instruction, which requires only one control step to complete by decoding the instructions, and add operation takes place in a single step. So the R4 out and R5 out, select A, add operation, and R6 is going to be loaded, and it's going to give the instruction as end of the particular instruction execution. Such a way it's going to provide more paths for data transfer, a significant reduction in the number of cycles which have been needed to execute the instruction is going to be achieved over there. Okay, so 3 different buses are going to operate for taking the data R4, taking the data R5, and feeding the data R6. So all are going to be connected, all are going to be conducted in parallel. Such a way, what happened, the number of clock cycles in a single clock cycle, this is going to be happen over the execution cycle has been completed with one control step, nothing but one clock pulse, one clock signal. Such a way it's going to do its operation with a single step. The execution is going to get completed, so which is going to be more easier, more efficient when compared with the single bus organization. Okay, so let us discuss about the particular information, how it has been. So as we have seen about that, the add R4, R5, R6 instruction, a 3 operand instruction which have passed the content to the program counter through ALU and load into the memory address register. During that time, it's going to increment the program counter. During this increment time, the content of this new data will not affect the fetching cycle of the ALU. Okay, and it's going to wait for the memory function complete, then transfers the data into memory data register through R equal to B, and it's going to be transferring into the instruction register. Okay, then finally it's going to complete the execution of the instruction with one step, and it's going to end the process. So that by providing more paths of data transfer, a significant reduction is going to be happen in the number of clock cycles and which is needed to execute an instruction. Okay, here it's going to get achieved. Let us discuss about the advantages of this multi-bus organization over a single bus organization, which is a more speed and which is going to be a more efficient system. How the multibuses permits several devices to work simultaneously and reducing the time spent waiting and improving the computer speed. Speed of operation is going to be get improved over there. And meanwhile, which is going to be performance improvements are the main reason for having multiple buses in a computer design. Second advantage is nothing but expansion. Having the multiple different buses available gives you more choices for connecting the devices to your computer, as hardware makers may offer the same component for more than one bus type. Such a way expansion is going to be happen over here. And the third advantage, compatibility. Having a multiple bus that supports equipment from different eras let you keep legacy equipment such as printers and old hardware devices and new we can add a new devices as well. Such a way is going to be more compatible with the multi-bus organization. And multi-core, and last advantage is going to be multi-core. Most computers have adopted a multi-core model that requires additional buses. So to keep each core busy and productive, the new bus designs very increased amounts of information in and out of the microprocessors, which keeps a very minimum time for the waiting time. Such a way, these advantages are going to be more when compared with the single bus organization. Such a way, we are going to say that the multi-bus organization is going to be so more effective and it's going to be more efficient, and operation speed is going to be high, which has an expansion as well as more compatibility when compared with the single bus organization, and parallel processing multi-core operations are going to get performed with the help of multi-bus organization.